our last couple examples here, we're going to talk about multiplying and dividing. So hopefully you remember when you multiply fractions, and that's all we're doing here. You're multiplying fractions. You just do the top times the top and the bottom times the bottom. Okay, multiplying fractions is relatively easy. Now we still want to factor these out though, because whereas I can tell 8 and 15 don't have any common factors, that's harder to tell when they're expressions. So in fact, if you had written this in its factored form, 2 times 2 times 2 is 8, and the bottom is 3 times 5, we can tell, hey, there is no common factors, or there are no common factors we can cancel. So this cannot be reduced. Now when we do this with expressions, we're going to want to factor stuff out and then look for common factors. Maybe we can simplify the answer. So we're actually going to, rather than trying to say FOIL the top here with these giant numbers, we're actually going to factor them out first. So x minus 3, there's really nothing we can factor out of that, but I'm going to keep parentheses around it to remember that's its own factor. Okay, in the denominator here, we do have a common factor. There's a 2 that we can factor out of both of those terms. Dividing a 2 out of each of these leaves me with x minus 4. Okay, times. Now up top here, I believe 6 goes into both of those, so we can take out a 6 is a common factor. And that leaves me with x squared. Let's see, 6 goes into 9 once, with 3 left over, and 6 goes into 36 6 times. X squared minus 16. And then the bottom, is a difference of squares. X plus 3, x minus 3, pretty common one. And you might even notice, hey, we've got another difference of squares up here once we took our 6 out. So yes, let's go ahead and break that down as well. So this is the first fraction, not changing anything here, I'm just going to rewrite it. And then factoring out that x squared minus 16, that would be x plus 4 times x minus 4. And in the bottom, x plus 3, x minus 3. So now everything is as factored as possible. And remember, it's the top times the top, the bottom times the bottom, so all of these things are just being multiplied. You can essentially think of this as one giant fraction now. Just trying to connect the bars, where everything's being multiplied. And now that it's all held with multiplication, we can look to get rid of common factors. But before we do that, remember, let's write the domain of the original. So what value or values would make our denominator 0? Well, 2 will never equal 0. But when will this factor equal 0? When x is positive 4. So we need to exclude positive 4 from that. We're going to need to exclude negative 3 for that factor. And we're going to need to exclude positive 3 from that factor. So x could be any number except positive 4, negative 3, and positive 3. There's our domain. Now let's go ahead and simplify. So looking in the top and bottom, I see an x minus 4. Again, as long as everything's held with multiplication, they don't need to be right above and below each other. They're just common factors. I see an x minus 3 we can also get rid of. And the 6 and the 2 have a common factor, right? We really didn't break 6 down, but typically with numbers, we can figure them out without having to go to prime factors. If we divide each by 2, this would become a 1, and this becomes a 3. So looking at what we have left after we've gone through and simplified, the only things up top is we have a 3 times x plus 4, 3 times the quantity x plus 4, and you don't need to multiply that back through. And in the bottom, the only thing we have left is x plus 3. And since it's the only thing in the bottom, you can omit the parentheses if you want. If you wrote them in, it's not terribly wrong. They're just unnecessary. But the reason we might not multiply the top back together is just to show that there are no common factors for sure for anybody reading our answer. So that's it. Here's our simplified answer and our domain with the excluded values. Okay, so when you're multiplying, factor everything out. Top times top, bottom times bottom, you can start to think of it as one big fraction, and then just cancel all your common factors after you've stated your domain. Okay, so hopefully multiplying is relatively easy. Let's do our last one here, which is dividing. So you may remember when you are dividing fractions, if you're dividing by a fraction, that is the same as multiplying by the reciprocal. keep, change, flip, right? Keep the first one, change it to multiplication, flip the second fraction. Not a big fan of that, but multiply by the reciprocal, right? So now it's multiplication. Top times top, bottom times bottom. And of course, if you can simplify some things away, you would do that, right? There's a common factor of 2, and 6/5 would be the final answer there. Okay, so all we need to do in this problem to change it like a multiplication problem is to multiply by the reciprocal. So all we're going to do is flip this thing upside down. X squared minus 9, 15x cubed plus 45x squared. Okay, and then this fraction stays the same. Okay, now, yeah, let's go ahead and factor this out. Okay, so in the top here, it looks like we have a 5 and an x we can take out of our first fraction. And if we divide a 5 and an x out of there, from this term, we'd be left with x. Dividing by 5x, this would give me positive 2. Okay, so there's the numerator of the first part. Now down below, we have a quadratic. Let's see, the two numbers that multiply to -6, so they're opposite signs, and add up to -1. It's -3 and +2. Okay, so we factored the denominator here. Times, and now that we've already done our reciprocal, we have our difference of squares again, x plus 3x minus 3. And down below, let's see, we can take out an x squared as a common factor there. Oh, whoops, this is supposed to be 45. Apologies. Actually, we can take out a 15 and an x squared. So if we do that, taking a 15x squared out of that would leave us with x. And dividing that by 15x squared would give us positive 3. So here are all of our factors. All of these things held with multiplication. Remember, this is really one big fraction now when we're multiplying. Top times top, bottom times bottom. And let's state our domain before we start getting rid of things. So what would make the denominator equal 0? Ooh, well, don't forget we're going to have to do some extra stuff here. But we need to exclude positive 3 from that factor. We need to exclude -2 from that factor. We need to exclude -3 from that factor. Now 15 will never equal 0, but x squared, when would that equal 0? When I plug in 0 itself, right? 0 to any power would be 0. So this is what I have for my denominator here. But remember, x squared minus 9 was originally in our denominator as well. So we would need to exclude positive 3 and -3. Now, they're already in my list, but if they weren't, we would need to add them in. Anytime anything is in a denominator, an expression is in the denominator, there is a restriction on that variable, whether it be in the beginning or when we flipped it upside down, those both have to have it. In fact, the reason that both the top and bottom of this fraction can't equal 0 is because even if the top equals 0, we would be dividing by a fraction that has a value of 0. You can't divide by 0. So a good typical rule is just to say anytime anything is in the denominator, we need to exclude the value that makes it 0. Okay, our last part here, of course, let's simplify this. I see an x plus 3 we can get rid of. I see an x minus 3 we can get rid of. I see a 5 and a 15. If I divide each by 5, that gives me a 1 and a 3. An x plus 2 we can get rid of. Wow. And in fact, we have 1x, x to the first, and x squared. We can get rid of 1x between the top and bottom. And wow, what a big mess. But I think up top, the only thing we have left is a 1. And in the bottom, we have a 3 and x to the first power. 1 over 3x. That entire giant expression, all those calculations can be simplified into doing 1 divided by 3 times x, as long as x does not equal any of those restricted values. This gives me the same answer for x as this does, except I would have to exclude those values, right? But you can tell, I mean, if I'm writing a computer program and I need to do all of this, and I can instead do this and just tell it to skip those numbers, that's a heck of a lot of saving of time and computing power. Okay, so when you multiply, factor out top times top, bottom times bottom, state your domain, cancel your common factors or reduce them. Same thing when we were dividing. Multiply by the reciprocal. Flip this upside down, right? That's how we got this. Factor it all out. Look for common factors to get rid of. Don't forget to state your domain and exclude anything that was ever in a denominator. Okay, hopefully this lesson is relatively easy to understand. This chapter is going to get much more complicated, so please make sure that you have a good understanding of what we talked about here, what you can cancel and what you can't cancel. So next lesson, when we add or subtract, it's going to be a lot more difficult than this lesson. I wouldn't say it's crazy difficult, but you definitely need to understand this to move on. So if you have questions, make sure you ask in class.